Hi there. What we're going to be working on right now is taking all that trig that we know and using it to solve word problems and application problems. So this really hinges on drawing a diagram that is accurate. So let's look at the first problem. It says we have a painter using a 25-foot extension ladder to paint the high points on a house. And the ladder makes a 38-degree angle with the ground. So let's think about this. If we have our house over here, here's the ground. The ladder is going to be looking something like this. Okay, so there's our ladder. And it tells us that the ladder is 25 feet. And it also tells us that it makes a 38-degree angle with the ground. So that means this angle right here is 38 degrees. What it's asking us to do for part B is to figure out how far up the house the ladder reaches. So we're looking for this side right here. Of course, we're assuming this house is perpendicular to the ground, and we have ourselves a right triangle trig problem. So looking from the 38 degrees, we have to label our sides. Well, no matter what, this ladder is the hypotenuse, right? It is opposite the right angle. And if you look from the 38 to the x, they are clearly opposites. So which trig ratio uses opposite and hypotenuse? Well, you should know by now that it's sine. And so we're going to write ourselves a trig ratio that the sine of 38 degrees equals opposite, which we don't know, over hypotenuse, which is 25. And of course, in order to solve any problem like this, we cross multiply. You might think of it as cross multiplying or multiplying by 25. And what we get is x equals 25 times the sine of 38. And you're just going to drop that in your calculator and we will estimate the answer. What you should get in your calculator, and please make sure you do it, is that the ladder reaches 15.4 feet up the side of the house. So this right here is 15.4 feet. Okay. The second question asks us how far from the house is the base of the ladder. Well, here's the base of the ladder. Here's the house. So we're looking for this distance right here. Now again, let's look at using SOHCAHTOA here. We could use Pythagorean theorem now that we have two sides, but we're not going to. So we'll look at what we've been given, which is that our hypotenuse is 25 feet. We have an angle that's 38 degrees, and this side that I labeled in pink would be the adjacent side. So again, we ask ourselves which trig ratio uses adjacent and hypotenuse. Think SOHCAHTOA. So it's cosine. So we have the cosine of our given angle is equal to the adjacent side length, with which we don't know, so I'll call that y, seeing that we already used x. So y divided by 25. And once again, we'll be multiplying, so we get that y equals 25 times the cosine of 38. Drop that in your calculator. Make sure you're getting these answers. You should have gotten 19.7 degrees. And if you're not getting these answers, make sure you're working in degrees. Make sure you're hitting cosine when you're supposed to hit cosine and sine when you're supposed to hit sine. Okay, just be real careful. Okay, example 2. Example 2, we have a boat leaving a port, traveling 25 miles due north. And then it turns and it travels due east for 40 miles. So we're going to draw ourselves a diagram. This is the port. It went 25 miles due north. So we'll make sure to label that 25 miles. It then turned and went 40 miles due east. We know that that makes a right angle, doesn't it? North and east are perpendicular. And the first question here is how far is the boat from the port? How far is the port from the boat? So here's our boat right here. Here's our port. We're looking for this distance right here. So we'll call that x. Well, think about what we have here. We don't have any angle measures. We have two sides of a right triangle, and we're looking for the third. And that's a definite time when we're going to use Pythagorean theorem. So a squared plus b squared equals c squared. So we have 25 squared plus 40 squared equals c squared. And to tell you the truth, you could just drop this right in your calculator just like this, because we're allowed to get decimal answers for these. We're not looking for exact radical answers because they're application problems. So if you didn't want to do that, you could have simplified this to be 2,225. Okay, and then take the square root of that. Either way, you're going to find that it's 47.2 miles from port. Okay, so 47.2. And that makes sense because it should be the longest side of the triangle, and it is. So the second question, using the same diagram, asks us for the measures of the two acute angles of this triangle. So I say we look at this one first, the one right where the boat is. And I would like to use these two legs of the triangle because they are exact values, whereas the hypotenuse is approximated. So the 40 is adjacent to the angle that we're working with. The 25 is opposite. So what trig ratio uses opposite and adjacent? Should know that that's tangent. So tangent of theta equals opposite, which is 25, over adjacent, which is 40. And remember, when we're trying to find an angle, we take the inverse. So we have inverse tan of each side. So in your calculator, you're going to put inverse tan of 25 over 40, and you should get approximately 38 degrees. I'm sorry, 32 degrees. Okay, so put that in your calculator, and you should get 32 degrees. Now, this is really simple. We know that these two angles add up to 90 degrees. Okay, so what we can do for the other angle is just say 90 minus 32 degrees. And we find out that that other angle is 58 degrees. Okay, and if you think about all three angles of a triangle add up to 180, if this is 90, it left 90 for these two angles. Okay, a little bit more. So we will have word problems with the angle of elevation and the angle of depression. So the angle of elevation is the angle between the horizontal line and the line of sight from an observer to an object at a higher level. So if you can picture, if you had to look up at a mountain, it would be the horizontal would be here, and then you'd be looking up here. So this would be your angle of elevation. And this is our horizontal right here. It always has to go off the horizontal. For angle of depression, it also goes off of a horizontal, and then it's how far down you have to look at something. So if someone was at the top of the mountain and they wanted to look down at you, the angle of depression would go from their horizontal line of sight and then down to you. That would be the angle of depression. And if you think about these two lines are parallel lines, and this goes way back, but the two parallel lines cut by transversal, alternate interior angles are congruent. So the person down here looking up to the top of the mountain to their friend, they have the same angle that this person up here has to look down. Okay, so just a real quick example. If they had to look up 50 degrees, the other person had to look down 50 degrees because, again, it's always off of that horizontal. So let's go ahead and do an example and see what this looks like. So it says Kelly's looking out her second story window and she sees Miranda across the street. Kelly's 18 feet above the street, and she looks at an angle of depression of 32 degrees to see Miranda. How far is Miranda from Kelly? Okay, let's get this straight. Kelly's in the second story. That is 18 feet above the street. So here we go. This is Kelly, and she's 18 feet above the street. And she sees her friend Miranda. Just put an M here. In order for her to see Miranda, she must look at an angle of depression of 32 degrees. So we have to pretend she's looking horizontally and then go down from that so she can see Miranda. And this is a 32-degree angle. Now you might think, well, wait a second, that angle's not even inside the triangle that we're working with. Well, fortunately, we have two parallel lines cut by this transversal. So if this angle is 32 degrees, this angle is 32 degrees as well. And now we have something to work with because we are asked to calculate the distance from Miranda to Kelly. So we're asked to calculate the length of the hypotenuse here. We've been given the length of the opposite side. Okay, I'm going to call the hypotenuse x. So which trig ratio uses opposite and the hypotenuse? Hopefully you remember it's sine. So we have the sine of 32 degrees equals the opposite over the hypotenuse. Now we have a little more work to do on this one because our variable is in the denominator, but it starts the same. We multiply by x on each side. We get x times the sine of 32 equals 18. And now we say, well, how are we going to isolate x? We should be dividing by the sine of 32 on each side. And once again, just like we've been doing, it's really just all dropping this in the calculator. So 18 divided by the sine of 32, we should get that they are 34 feet away from each other. Okay. What I'd love for you to do right now is to pause the video and see if you can figure out how to do example 4, and then maybe turn the video back on and see if your answer matches mine. Okay, so check your work. Hopefully you also got about 153.9 feet for the height of the tree. Okay, check your diagram, check your work in your calculator, and hopefully you did all right. Have a great day, everybody.